Good afternoon, everyone. So for today, our topic is about fossil fuel formation, energy resources and the generation of electricity, impact of oil pollution, and management of oil pollution by the report of Group 1. What is the fossil fuel formation? Fossil fuel, any of a class of hydrocarbon containing materials of biological origin occurring within Earth's crust that can be used as a source of energy. Fossil fuels include coal, petroleum, natural gas, oil shales, bitumen, tar sands, and hairy soils. All fossil fuels can be burned in air or with oxygen derived from air to provide heat. This heat may be employed directly, as in the case of home furnaces, or used to produce steam to drive generations that can supply electricity. In still other cases, for example, gas turbines used in jet aircraft, the heat killed by burning a fossil fuel serves to increase both the pressure and the temperature of the combustion products to furnish motive power.
I am Jean Grace O. Ayoc, and I will be discussing what is energy resources. When we say energy resources, it is a natural resource that can be converted by humans into other forms of energy in order to do useful work. This was composed of two categories. First is the non-renewable resources, and the second is the renewable resources. Non-renewable resources cannot be replaced after they are used, or can be replaced only over thousands or millions of years. Fossil fuels is an energy resources that formed from the buried remains of plants and animals that lived millions of years ago. Energy from fossil fuels forms from the sun's energy. The most important non-renewable resources are the coal, petroleum, and natural gas are the most common. Coal is burned to produce steam to run electric generators. Petroleum, it supplies us with gasoline, kerosene, and wax. And lastly, the natural gas is used in heating systems and in stoves and oven. The second category of the energy resources was the renewable resources. It can be used and replaced in nature over a relatively short period of time. And examples of renewable resources are the solar, hydro, wind, geothermal, and the biomass. Solar. A sunlight can be converted into electrical energy through solar cells, found in calculators or used in a home for electrical energy or thermal energy that heats the house. Second was the hydro. A potential energy of water in a reservoir is converted into kinetic as the water flows downhill through a dam. Falling water turns a turbine in a dam, which converts kinetic energy and into electrical energy called hydroelectricity. Third is the wind, caused by the uneven heating of the Earth's surface, which creates currents of air. Kinetic energy of wind turns the blades of a windmill. It converts kinetic energy into electrical energy. Fourth is the geothermal. It results for the heating of the Earth's crust. Water turns to steam, which is then used to turn a generator to produce electrical energy. And lastly, is the fifth was the biomass. An organic matter such as the plants, wood, and waste are the burned to release energy.
Electricity generation is defined as electricity generated from fossil fuels, nuclear power plants, hydropower plants, geothermal systems, solar panels, biofuels, wind, and etc. It is the process of generating electric power from sources of primary energy. For utilities in the electric power industry, it is the stage prior to its delivery to end users or its storage. Electricity is not freely available in nature, so it must be produced. There are various methods of electricity generation dependent on types of energy. Among resource energies, Coal and natural gas are used to generate electricity by combustion, uranium by nuclear fission, to utilize their heat for boiling water and rotating steam turbine. Among renewable energies, sunlight is directly converted into electricity. Rotation energy by wind is converted into electricity. Rotating water wheel by running water to generate. Magmatic heat boils underground water to rotate steam turbine to generate. Continuous technology development for them are proceeding to convert resource energies or renewable energies into electricity with less loss. It is also important for the operation of power plant to do maintenance or training of operators. What are the different types of power plants used to generate energy? As a number of countries continue to move away from high-polluting fossil fuels towards low-carbon alternatives, the dynamic of how and where power plants operate is constantly changing. Nuclear, coal, and wind are just three types of energy that are used to generate electricity in power plants across the world. But as a number of countries continue to move away from high-polluting fossil fuels towards low-carbon alternatives, the dynamic of how and where power plants operate is constantly changing. According to Bloomberg NEF, global electricity demand will grow from 25,000 terawatt-hours in 2017 to about 38,700 terawatt-hours by 2050, which will drive new investment in power generating capacity in the coming years. Here, NS Energy profiles the different types of power plants each power source needs to generate energy. Types of power plants for energy generation. First, the nuclear power plants. Using a nuclear fission reaction and uranium as fuel, nuclear power plants generate a high amount of electricity. As nuclear power plants are considered to be a low-carbon energy source, the technology is widely thought of as a more environmentally friendly option. When compared to renewable sources of energy such as solar and wind, the power generation from nuclear power plants is also considered to be more reliable. Although the investment required to bring a nuclear power plant online is significant, the costs involved in operating them are relatively low. Nuclear energy sources also have a higher density than fossil fuels and release large amounts of energy. Due to this, nuclear power plants require low quantities of fuel but produce a vast amount of power, making them particularly efficient once they are up and running. Second is the hydroelectric power plants. Hydroelectricity is produced by harnessing the gravitational force of flowing water. Compared to fossil fuel-powered energy plants, hydroelectric power plants emit fewer greenhouse gases. The third one is the coal-fired power plants. According to the World Coal Association, coal-fired power plants accounted for about 37% of global electricity in 2018, with China possessing the world's largest fleet. Coal-fired power plants use steam coal as a source to generate electricity and consequently emit a significant amount of harmful gases into the atmosphere. In a bid to reduce greenhouse gas emissions, many developed nations have already announced plans to phase out coal-fired power plants. Canada plans to phase out its coal plants by 2030, while the UK has set a deadline of 2025 and Germany is aiming to remove the technology from its electricity grid by 2038. A number of other European countries are expected to following suit soon. Diesel-fired power plants. Using diesel as the fuel, this type of power plant is used for small-scale production of electric power. They are installed in places where there is no easy availability of alternative power sources and are mainly used as a backup for uninterrupted power supply whenever there are outages. Diesel plants require only a small area to be installed and offer higher thermal efficiency compared to coal-fired power plants. Due to high maintenance costs and diesel prices, the power plants have not gained popularity at the same rate as other types of power generation plants such as the steam and hydro. Geothermal power plants. The three main types of geothermal plants include dry steam power stations, flash steam power stations, and binary cycle power stations, all of which use steam turbines to produce electricity. Gas-fired power plants. A gas-fired power plant burns natural gas, a rapidly growing energy source across the world, to generate electricity. Although natural gas is a fossil fuel, the emissions produced from its combustion are much lower than those from coal or oil, according to a study by the Union of Concerned Scientists. Data from the International Energy Agency shows that gas-fired power generation expanded by 3% in 2019, taking its power generation in the global mix to 23%. Another type of plant that uses gas is a combined cycle power plant. Using both gas and steam turbines, they produce higher amounts of electricity from a single fuel source compared to a traditional power plant. They capture heat from the gas turbine to increase power production and are also found to release low amounts of harmful gases into the atmosphere. Solar power plants. Solar energy plants convert energy from the sun into thermal or electrical energy using one of the cleanest and most abundant renewable energy sources. They generally do not require high maintenance and last for about 20 to 25 years. Wind power plants. In recent years, there has been a rapid growth in the number of wind farms across the world, underpinned by technological advancements. Global installed wind generation capacity onshore and offshore has increased by a factor of almost 75 in the past 2 decades, jumping from 7.5 GW in 1997 to 564 GW by 2018, according to the arcayna. After the wind turbines are built, operational costs involved in maintaining wind power plants are low and they are generally considered to be relatively cost-effective. Wind farms can also be constructed on agricultural lands without causing any interruption to cultivation activities. But the maintenance of wind turbines may vary, as some need to be frequently checked and wind power projects typically require huge capital expenditures. Tidal power plants. Tidal energy is generated from converting energy from the forest tides into power, and its production is considered more predictable compared to wind energy and solar power. But tidal power is still not widely used, even though the world's first large-scale plant of its type became operational in 1966. An increased focus on generating power from renewable sources is expected to accelerate the development of new methods to exploit tidal energy. Although the development of tidal power is at the nascent stage, it has the potential to grow significantly in the coming years.
Pollution of every kind is harmful to nature. Oil pollution in particular is a kind of water pollution, and a dangerous one at that. Oil does not dissolve in water, and hence, oil usually floats on the surface of water. Oil pollution due to any cause greatly affects the quality of natural water bodies and is classified under pollution. Oil pollution is the resultant contamination of the environment due to the introduction or presence of oil in excessive quantities. The following are the impact of oil pollution. Damage to ecosystem. Oil pollution is a major threat to our ecosystem, especially the aquatic ecosystem. It greatly decreases animal breeding, population and also harm their nesting habitats. This leads to the consequent shrinkage of the local prey population, unbalancing the aquatic food chain and ecosystem. Plants in the water also cannot survive in poisonous oily environment and die a premature death ahead of their life cycles. Second, damaging effect marine biodiversity. Marine biodiversity will get great affected by oil pollution. It can cause potential harm to the marine birds, aquatic animals, and mammals. Feathers of marine birds get coated with the oily water, which hampers with the water-repelling property of their plumage. This might increase their chances of drowning in water as their buoyancy might considerably decrease. Aquatic animals and mammals may tend to ingest the oily contaminated water, which could mean harm to their health by poisoning them. This may adversely affect their body temperature maintenance. Third is economic loss. Oil pollution is proportional to a considerable economic loss. Spillage of crude oil is of great loss as crude oil is precious and very expensive. Oil spillage, if happens in high concentrations, is very difficult to clean, no matter how much effort is invested into it. Also, the cleanliness regime is anything but cheap. Huge amount of money need to be spent to tidy up the oil spillage mess, and then also the result may not be 100% satisfactory. Fourth, altering the water temperature. The oil layer present at the surface of water will tend to absorb more heat from sun rays and may significantly increase the surface water temperature. It might block the sunlight from reaching into the depths of water with an even heat distribution across the depths of the water body. This can alter the natural hydrodynamics of the water bodies, which may lead to lesser oxygen supply at certain depths of water. Fifth, effect on coastal areas. The oil-contaminated water is usually swept across the shoreline by the waves in high tides. This makes the beaches dirty and unsafe for the human population. The shorelines and sandy beaches in coastal areas is an indirect victim of oil water pollution. Thus, coastal areas are continuously contaminated due to oil pollution. 6. Degrades water quality. Oil pollution seriously degrades the water quality on a long-term basis. Being insoluble in water, oily water always exists as bilayer. Also, at the shorelines, the current of waves might even turn the oily water into a turbid oil-water emulsion, wherein the oil and water exist as single turbid phase due to constant mechanical mixing forces. This degrades the quality of water further. 7th, tourism industry affected. Tourism industry is greatly affected by oil spills and oil pollution. Due to increasing oil pollution on beaches and shorelines, recreational activities of tourists like boating, swimming, diving, adventure sports are taking a back seat. Unclean and healthy water will repel tourists from undertaking these activities completely. 8. Industry problems. Many industries use clean water from natural water bodies for cooling purposes. Industries may also pose a risk of getting oily and contaminated water due to oil pollution. These industries may also pose a risk of getting oily and contaminated water due to oil pollution. Industries like power plants, nuclear plants, and desalination plants need constant water supply from surface waters. This may lead to contamination in their pipes and might not yield effective cleaning. Effects to human. Health problems due to the exposure to spilled oil or its volatile compounds may appear. oil spill pollution diseases are obviously not restricted to fishermen, affecting the population or the residents living in the affected area alike. Large oil spills, which usually occur in the oceans, affect commercial fishermen, seamen living in the affected areas, and ship workers on the ships near the oil spill location. Fishermen are directly affected by large marine oil spills that contaminate the fish species swimming in the oil-polluted water, along with ecosystem livelihoods. Seamen can be affected if they bathe in contaminated water. For example, swimming in a contaminated water stream. Even when an oil sheen may not be visible, dissolved oil contaminants may exist in the water. Last but not least, ship workers can inhale the fine particulate matter resulted from oil spills.
There are 10 methods in order to manage the oil pollution. First, using oil booms. The usage of oil booms is a simple and widely used way of managing oil spills. Containment booms operate as a barrier to keep the oil from spreading or drifting away. This procedure is only successful when the oil is concentrated in a single location. It only works if the spill is accessible within a few hours after its occurrence. Otherwise, the spill area becomes too huge to control. It cannot be used successfully in strong seas, high wind speeds, or changing tides. Second, using skimmers. After the oil has been contained using oil booms, skimmers or oil scoops can be put onto boats to collect contaminants from the water surface. Skimmers are devices that, like a vacuum cleaner, suck up oil from the water surface. They are used to physically separate oil from water so that it may be collected and processed for reuse. Using sorbents. Sorbents are substances that absorb liquids by absorption, drawing in through force or adsorption, forming a layer on the surface. Both of these characteristics make clean up considerably easier. Hay, peat moss, straw, and vermiculite are all typical oil sorbents. In situ burning. The oil floating in the surface is burned in this way to burn it off. This method of in situ oil combustion may efficiently remove up to 98% of an oil spill, which is greater than the most other approaches. Fifth, the use of dispersants. When booms are unable to contain the spilled oil, the only alternative is to expedite the decomposition of the oil. Dispersal agents such as cork seat 9500 are chemicals that are sprayed over the spill using airplanes and boats to aid in the natural breakdown of oil components. By expanding the surface of each molecule, they allow the oil to chemically bind with water. This prevents the slick from spreading across the water surface and makes it simpler for bacteria to break down. Sixth, hot water and high pressure washing. This process is mostly employed when chemical removal methods such as booms and skimmers are ineffective. It is used to remove trapped and aged oil from the area that are normally inaccessible to machines. Water heaters are used to heat water to roughly 170 degrees Celsius before spraying it with high-pressure wands or nozzles by hand. As a result, the oil is discharged to the water surface where it may be recovered using skimmers or servants. 7. Using manual labor. The procedure, as the name implies, necessitates the use of handheld instruments and manual labor to remove impurities. It entails cleaning the surface oil and oily debris with physical tools such as hands, rakes, and shovels, and placing it in designated containers to be transported off the beach. Number 8. Bioremediation. The employment of specialized microbes to eliminate poisonous or dangerous compounds is referred to as bioremediation. Petroleum products, for example, are degraded by diverse bacteria, fungi, archaea, and algae by metabolizing and breaking them down into smaller, non-toxic compounds, mostly fatty acids and carbon dioxide. Reagents and fertilizers may be introduced to the area on occasion. These phosphorus and nitrogen-based fertilizers give sufficient nutrition for microorganisms to thrive and replicate rapidly. This procedure is normally not employed when the spill occurs in the deep oceans, but it is progressively applied after the oil reaches the shoreline. Number 9. Elastomizers chemically stabilize oil. The initial priority following an oil spill is to keep the oil from spreading and polluting the surrounding regions. While mechanical approaches such as utilizing oil booms successfully confine the oil, they have some limits. To contain oil spills, experts have lately used substances such as elastol, which is essentially polyisobutene in a white powdered form. The component gelatinizes or freezes the oil on the surface of the water, stopping it from spreading or leaving. Furthermore, the gelatin is easy to recover, making the operation extremely efficient. Number 10. Natural recovery. The most basic approach of dealing with the oil spill cleaning operation is to rely on natural forces such as the sun, wind, weather, tides, or naturally existing bacteria. It is employed when the coastline is too far or inaccessible, or when the environmental effect of cleaning up a spill would greatly exceed the advantages. Because of the consistency of these constituents, the oil usually evaporates or degrades into simpler components.